Today, I'm going to talk about probability. I'm going to talk about 4.1, 4.2, 4.3. What is probability? Well, we talked about in the first unit, we talked about statistics and the actual calculating of data and obtaining data. Well, what is probability? Well, I like to give a layman's definition. I like to say it's assigning a number to an event. Predicting the outcome. The number is usually a decimal between 0 and 1. 1 being likely, 0 being unlikely, and 0.5 being in the middle. These are decimals. Usually you don't see percentages in probability, you see decimals. If you want to say there's a probability of 0.75, you say it's a 0.75 probability, or a 75% chance. Usually chance goes with percent, probability goes with the decimal. There are some teachers that say, 75% chance is just as good as 0.75 probability, but I had professors go with this when talking about probability. And can we predict? Can we predict what's going to happen? Can we predict the future? No, we cannot. But we cannot predict the future like what's going to happen to you 10 years from now. If you're going to have a boy or a girl, if you have a baby, we can't predict the future like fortune telling. But what we can do, let me give you an example. You get behind slow cars all the time. You get behind slow cars and then they only go 35 miles an hour in a 55 zone, and you got to go down. Some of you may know Wild Hog Road, going to Pendleton, and it's a long road. It's 2-lane road. It goes to Pendleton, and then you turn left in Pendleton to go to Pendleton campus, and turn right to go to Anderson. Well, you get on this road, and it's about, 8-9 miles long. I don't know how long it is, but if you travel this road enough, you always get behind one person that's going 35 miles an hour on a 55 zone or 45 zone or whatever the case may be. In other words, they're always going 10 miles per hour lower than what the speed zone is or whatever the speed limit is. And you come up to this red light in Pendleton, and there's a left turn lane and there's a right turning lane. If you're late for an 8 o'clock class and you're behind this person, all the times you get behind that person, you can pretty much predict that they're not going to turn right and go to Anderson. They're going to turn left because you've been behind them all these times, and you know that you're in a hurry and you're late for class, and the worst thing that could happen is going to happen, and that means that person is going to turn left. You can predict that because of the past times you have been going down this road. That is what kind of prediction we're talking about. Something that you've observed, something that you can calculate and assign a number between 0 and 1. Now I keep saying between 0 and 1 because that's very important. You need to realize that everything in probability is based on this scale from 0 to 1. And have to keep mentioning that. In probability, you have events and you have sample space. Events are like picking a card out of a deck of cards. You try it and you experiment and you do it one after the other. You try to find the probability, and I'll just say card out of a deck. And a sample space would be what's the probability of having 3 children, a couple having 3 children with 2 boys and a girl. Well, you have to list all the outcomes of those 3 children, and that would be girl, 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 boy, girl, boy, girl, girl, and so on. And you get about 8 of them. And then you pick the probability of having 2 girls. This is a sample space, and this is an event. So let's say that we are talking about 2 boys and 1 girl. What is the sample space? Well, we'll continue this, and that's girl, 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 boy, girl, and then you could have girl, girl, boy, and girl, boy, girl, we got that one, and boy, boy, girl, boy, girl, boy, and boy, girl, girl, we got boy, girl, girl, we got girl, boy, boy, don't have girl, boy, boy, and boy, boy, boy. I think there's 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there's 8. And then you pick how many out of 8 is 2 boys. And the probability of 2 boys is how you write it. And 2 boys. Well, let's see. Where's a boy? 2 boys, 2 boys, 2 boys. There's 1, there's 1, and there's 1. And that would be 3 out of 8. And that's your probability. It would be a decimal between 0 and 1. And that's how you do a sample space. Usually they will tell you set up a sample space. Now an event, you do these a good bit. What is the probability of picking a king out of a deck of cards? Well, if you're not familiar with a deck of cards, there's 52 cards in a deck, and there's 4 kings, 4 different suits of a king in a deck. So your answer here would be 4 out of 52, and that would reduce down to a fraction, a decimal between 0 and 1. What about the probability of picking an even card? Probability of picking an even card, and it'll have to give you a note like ace is equal to 11, or ace is equal to 1, or whatever the case may be. So we'll draw a picture. Let's see, we got a card here. That's a 2, and then a 3, and then a 4, and then a 5, 6, 7, 8, 9, 10. Got our ace. Oh, sorry. Let's see. Got our king, queen, jack, and ace. Alright, we know that's 11, so it don't count because we won't even. There's an 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 even. And then we got evens here because face cards are 10. So I think we got everything. So that'll be 1, 2, 3, 4, 5, 6, 7, 8. So your answer would be 8 over. Now that would be 8 out of a suit. So that would be 8 times 4, which is 32 over 52. And that would be equal to some decimal between 0 and 1. Now you don't have to draw a picture like this, but it does help if you don't have a deck of cards to actually, or if you don't know a deck of cards as well as some people, to actually use pictures. You can do this with a die. Think of a die. And of course a die is a cube, and it has 1 dot, 2 dots, and 3 dots, and then 4 dots on the bottom, and then a dot over here, which is 5, and then 6 on this side, and 5 on this side. So we got 6 sides. What is the probability of rolling a 6? Well, that would be 1/6, and that would equal to a decimal between 0 and 1. What is the probability of rolling an even number on a die? That would be 3 out of 6, which is equal to 0.5. So it's somewhat likely because it is halfway between 0 and 1. And that's how you do events, probability of events. And then there's some questions that might trick you or try to trick you. Like, for instance, what is the probability of rolling a 7 on a die? Well, it's 0. Why? Because you can't roll a 7 on a die. What is the probability of getting 6 kings out of a deck of cards? 0. You can't get 6 kings, you can only get 4 kings. So these are some little, I wouldn't say trick questions, but just watch out for these type questions because they will get you on a test. And they're real simple. So those are a couple of events that kind of get people off guard. Talk about the 2 types of probability. I like to call them the theoretical probability and the physical probability is what I like to call them. The theoretical is in theory. I don't even know how to spell theoretical, but I'll do the best I can. Theoretical probability and the physical probability. Different books call it different things. This is what Hubert calls it, so this is what I'm going to use. The theoretical probability is the predetermined calculated probability based on the features of the object or the features of the event. Pre-calculated probability of event based on the object that's actually being used or the event. Let me give you an example. We said a while ago that the probability of rolling a 6 on a die is 1/6. We didn't roll a die. we just counted up the sides of the die, which is 6, and then took one of the numbers and said 1/6. That's a pre-calculated probability. The probability of picking a king out of a deck of cards is 4/52. We don't even have a deck of cards, but we already had that determined, and we didn't have to do experiment or buy a deck of cards or anything. We just used our knowledge of the subject, our knowledge of the object or the event, and predetermined or pre-calculated a theoretical probability in theory. And that's what I like to call these type of probabilities. Another, the probability of getting heads on a coin is equal to 0.5, because there's a head side and there's a tail side of a coin. So it's predetermined, it's pre-calculated that you got a 50% chance of getting either one. Physical probability is basing your calculation of the probability on observations. Or attempts. That would be rolling a die 10 times to see the probability of a 6. That would be an example of a physical probability. And let's say you rolled it 10 times and it came up 4 times with 6, then that would be a 0.4 or 4/10 probability. The number of actual events over the number of tried events. And we'll get into that in just a minute. Okay? Another experiment would be actually shuffling a deck of cards and picking one card to see if it's a king. And you do this 10 times. You don't pick 10 cards out. You pick a card, put it back in, shuffle the deck 3 or 4 times, pick another card, shuffle the deck 3 or 4 times, put it back, shuffle the deck 3 or 4 cards. You do that 10 times. And let's say you picked a king out 1 out of 10 times. That's equal to 0.1. Well, we said the probability of picking a king is 4 out of 52. And if you do 4 out of 52 with your handy dandy calculator, you're going to get, 4 divided by 52, 0.07, which they don't equal. Probability of a king is 4 out of 52, which is equal to 0.07. Now, even though that rounds to 0.10, this was just a number that I picked up. I didn't do the experiment. But these two are not equal. Same thing with flipping a coin. If you flip a coin ten times, and you want to find the probability of heads, well, the probability of heads, you flipped it 10 times, it came up to be 6. That's equal to 0.6. Well, we said that the probability of heads calculated is 0.5 because you got 2 sides. So again, these two don't match. So that leads us to the large number rule. The large number rule states that the more times you conduct an observation, an event, whatever you want to call it, comma, the closer the physical probability gets to the theoretical probability. Now, the reason we go over the large number rule is to substantiate events. When you do some probability experiments, or when you go about trying to find out if the probability of a sample or is going to be a predictor of the population, then you need to have this in mind. You don't need to go out and interview 10 people. You need to go out and interview 1,000 people. You don't need to go out and measure 6, I don't know, car spaces. You need to go out and measure 60. The large number rule basically says the more numbers you do, the better your probability is, or the more valid your probability is. So just remember the large number rule. It's in your book, and it just sets the tone for whenever you conduct an experiment or an event. You don't need to do it just one time and say, okay, the probability is 0.7. You need to do it more than one time. Okay? And that's basically 4.2. Oh, forgot to mention odds against and odds in favor. Let's go over that. That's the last part of 4.2. Odds against and odds in favor, usually that's when we're talking about gambling. Actually, you know, what are the odds against something happening? In gambling, if the odds are very high or the odds are very low, then you don't make much money. If the odds are very high, then you make more money. So let's discuss that right quick, odds against and odds in favor, and also talk about the complement. The complement is what's left over from the unit of 1, or the whole. I like to say the whole because sometimes it doesn't equal 1, sometimes it equals a whole bunch of numbers. So let's talk about the complement. Just a second. I want to make sure that I'm supposed to talk about, the complement is, I like to tell my students that the complement is like if you have $1 and you give 65 cents of it away, then you have 35 cents left. That's a complement. In other words, if you have $1, if you have $1 and you give 65 cents away, I can't spell today, then the complement is 35 cents. Because that's what you have left. That's one example of a complement. Another example of a complement: if the probability is equal to 1, if the probability of an event is equal to 1, and you have the probability of, let's say, of it being tails, of the event being tails, like flipping a coin, and you say the probability is 0.6, then the complement, or the probability of not tails, which would be heads in this case, but I just put an X through tails, is equal to 0.4. Okay? The probability of an event is equal to 1. Let's say that we're rolling a die. What is the probability of rolling a 2? Well, that would be 1.1/6. Alright, that's 0.1666, I think. Well, then what's the probability of not rolling a 2? Well, the probability of not rolling a 2 is 5 out of 6. Because 5 plus 1 is equal to 6 over 6. There's 6 sides. So when you're thinking of a complement, you think of whatever's left over from the whole. And usually it will focus around 1 because 1 is the scale for probability. So that is what the complement is. The complement is what's left over from the probability. We also have one more thing to talk about, and that is the odds in favor and the odds against. And again, we're talking about gambling, and we're talking about winning money and things like that. So we're talking about making money from odds in favor and odds against. So what are the odds in favor and the odds against? The odds in favor are the probability of an event not happening over the probability of an event happening. The odds in favor are the probability of an event happening over the probability of an event not happening. Okay? So what I like to tell students is the odds against is equal to the probability of failure over the probability of success. Now, let me define success and failure. Success and failure is dependent upon the question. If you have a question, let's say, what is the probability of rolling a 6 on a die? All right, rolling a 6 on a die would be success. All right, and not rolling a 6 on a die would be failure. If you was to talk about flipping a coin, then the probability of getting, let's say the probability of getting heads. Well, heads would be success and tails would be failure. So let me just say this. Failure is equal to the probability of something not happening, where success is the probability of something happening. Let's call this the probability of tails. Okay, the probability of tails flipping a coin, that would be success. The probability of not tails, that's an X through a T, that would be failure. It depends on what your question is asking. What probability are you finding? The probability that you're finding is success. The probability of not finding it would be failure. So the odds against is the probability of failure over the probability of success. The odds in favor is equal to the probability of success over the probability of failure. So you need to remember both of these. And remember how to do these two. Now, I'm going to pull up a problem. I'm going to try to pull up a problem out of your homework. And that way, I hope I can find it. It's set with a roulette table. And it's usually the problem that causes everybody pain and suffering. So I thought I'd show it to you on the video so you would have it if I can find it. So hopefully I can find it, and it'll take me a minute. Should have already tried to find it, but oh well. There we go. Alright, a modified roulette wheel has 44 slots. If you don't know what a roulette wheel is, you need to look it up. One slot is 0 and the other one is 00. Okay, so 0 and 00, and then 42 numbered slots. Okay, and 1 through 42 are numbered. And they want to know, you are placing a bet, and your bet is that the outcome is an even number. Okay, so right there, when you're making a bet that the outcome is an even number, then what you're saying is that you're wanting the probability of an even number. So the probability of an even number is going to be our success. And the probability of not even number is equal to failure. Do not say odd, because these two are neither odd or even. And that plays into the answer. Okay, now how do you do it? Well, first you got to find the probability of success. Probability of an even number is going to be equal to, well, even is going to be half of 42, which is 21. So that'd be 21 over 44. And I don't know what 21 over 44 is, so I will calculate it right quick. Let's see. Well, I did have the calculator up. That'd be 21 divided by 44. And that's equal to 0.47 or 48. Actually, it's 47 repeating or 0.48. So now you know the probability of not even, because you're going to do the complement. And the complement of 21 to 44 is 23 over 44, because 23 plus 21 is equal to 44. And that's equal to, and then just take the complement of this, and that would be point, what, 6, I mean, not 6, 5, 3, 3 repeating, 5, 3 repeating, 5, 2 repeating, be 5, 2 repeating, wouldn't it? Or 0.52. Okay? Now, when you're dealing with that's your first part. Your first part is to find the probability of success and the probability of failure. That's your first part of this question. The second part is to find, hold on just a second and I will find the question. I think it asks for the odds against. Yeah, that's what it does. It asks for the odds against. It says the actual odds against winning. So that's part 2 of this question. Part 2 asks for the odds against winning. And that would be the probability of failure over the probability of success. Now when you do the odds, leave everything as a fraction, because that way everything will cancel out. Our probability of failure in this problem is 23 over 44. And we're going to divide that by 21 over 44. What do you do when you divide by a fraction? You multiply by the reciprocal, and the denominator and the numerator cancels, and that's why you use the fractions, and you get 23 to 21 odds. Now, the third part, they're going to ask you, what if you do if the odds are even and you bet $15? Well, if you bet $15 and the odds are even, in other words, 1 to 1, 2 to 2, 3 to 3, then you get $15 back. So you win nothing. There's no profit. Now, I disagree with this question a little bit because they ask for the profit, and I don't agree with what they do. But let me explain. They say with your odds, with these odds right here, 23 to 21, what is the profit won? What is the profit with a $15 bet? And a $15 bet, if you have a $15 bet, then you're talking about 15 times 23 over 21. And when you do that, let's see, 15 or 23 divided by 21 is equal to 1.09, and multiply by that by 15, you get back $16.43. Now the book says what is the profit, and then they asked you for $16.43, and I disagree with that because the profit that you made was $1.43, because you bet 15 and you got back 15, so you broke even at 15. The profit is $1.43, but they asked for the profit and asked for the whole thing, and I disagree with that. So I hope that helps you with 4.2.